Welcome to the Meltzone Podcast from February 8th, 2019. I'm Tom.
And I'm Stefan. And on today's video, we are going to talk about our current projects, cover my universal test machine I'm currently trying to make open source, some milling with Tom's experience in PCB milling and my, first steps in LinuxCNC. In news, we're going to talk about the Simplified 3D paid upgrade and also a, press release from the MIT where they talk about superfast DL pre-printing.
Do you get to introduce a few topics as well?
Sorry.
I get to do questions.
Yeah.
We also have two fantastic questions. We talk about MMU and what that is used for, what we would like to use it for, and whether we're using those at all. And we follow up on my idea of the arm-snapping, crazy speed, ignore all physics 3D printer, and whether the O-Drive is a good choice for that.
Perfect. And there's something new. We are talking this week about our favorite gadgets, and we're hoping that you guys like that section of the podcast. Otherwise, we come up with something different.
Stefan, how are you feeling today?
Better but not perfect. So I didn't really get fit over the last 2 weeks, just always had a cold, but I'm getting better, so I'm drinking tea.
Yeah, I can
that my voice is fine, and
we should do like one really smoky, rough episode where we both sound like.
Well, you already started coughing, so.
Oh yeah, I hope I'm not the next one who catches it. It seems like everyone I know is getting sick right now.
Yeah, it's horrible at the moment. I thought the flu season is over, but it's just about to start.
Yeah. I don't know. Man, human bodies are weird. Immune systems, you know.
Yeah, we just need to be totally fit when Murph is starting. So.
Oh yeah, it's actually not that far out anymore. It's only like 6 weeks, 7 weeks until we fly out.
Yeah, I'm already getting excited.
Yeah, and 3D Maker Noob.
Yeah.
Just announced that he's coming along too.
Yeah, that's great. So now just Maker's Muse is missing? I don't know.
Well, it's a bit of a long trip for him, but yeah, but I think he's been to Murph or somewhere, some Maker Faire.
He's been to a Bay Area Maker Faire, I think last year. But
not last year. Year before that, maybe. Last year I was there and he wasn't.
Yeah. But still, so many of the community are coming. Joel. 3D Maker Noob.
Daniel Norey is missing too this year, unfortunately. He couldn't make it.
But maybe next year. So still looking forward to meeting all the people you kind of just know from the internet, which is kind of strange, I think, at first. But still.
Yeah, I think we both are in kind of a really weird position, because when you're just in forums or in communities and you write back and forth, you're kind of like equals. Neither one of you or the other person knows what you look like and what you're like in person. But as a YouTuber, as someone who's literally filming themselves right now, it's kind of one-sided. People know you and think they know you more than you know them, and it's. Well, I wish I could have like a swappable face where I could go anonymous at some times, just conventions like that, and experience them as a regular visitor. But that's kind of past.
Yeah, that's past. I actually uploaded my first, I think, 20 or 30 videos just without any face, and I thought, just be part of the community. Let them know who you are.
It's
fun on the one side, but it can be stressful from time to time as well if you are on like the toilet and somebody's, hey, how are you? And, I don't want to talk to you now. It's kind of weird.
That's one of the places I never want to shake hands again. Yeah. I think Adam Savage has it pretty well figured out at Comic Cons, where he actually goes incognito. Incognito?
Incognito?
Yeah. But in costume, I mean, it's not the same thing, but it's something, right?
Yeah.
Right.
So I have seen that your YouTube videos are still not in 4K. What's happening there?
In fact, I have uploaded one just this afternoon, so a few hours before we started recording here. What I started doing now is I'm rendering out both a 1080p and a 4K video at the same time, and I upload both of them at the same time. And the thing is, the 4K one, the last video I uploaded, which is just, my video gear, I think that was that one, is still not processed in the 4K version. It's been like 12 days. It's almost been 2 weeks, and it's still at 720p, and in fact, it's not playable right now. The 1080p version of that, totally fine. Same with Jay's video, 35-minute video. Sorry, somehow I end up making these long videos, but yeah, 1080p one, totally fine, instantaneously processed. 4K one, let me check right now. Is not even at 720p. It's still 360. And you can't publish a video like that because you don't know if it's actually going to complete processing or if it's, just never going to finish. Nope. Still not in HD.
Well, we already got some bad comments last podcast when I just released the video when it was still not processed yet and just available in 360p.
360, yeah, that's the first one. But
and not only the videos, but also the audio has a way worse quality.
Yeah, I think people are confused for the most part because usually, we upload in decent resolution and have really crisp videos. But when all of a sudden it's like this mushy sounding and mushy looking video, is just, whoa, dude, what are you doing?
Back in 2010. But, well, you're not the only one, I think, who has problems with that. I've also seen Linus from Linus Tech Tips complaining about their videos not processing properly.
Yeah, it's, if there was like some indicator where it's like, no, we're just going to ignore this video and it's just going to sit on the shelf at 360p forever. If we knew that as creators, if you got that indicator, fine. Okay, I'll just re-upload. But the fact that there's like no progress bar or no, hey, we're working on this, or we have a queue of 5 hours until we can get to your video, that's kind of frustrating. So for the foreseeable future, at least from my side, you'll be seeing 1080p videos. I hope that's okay. I know some of my screen cap stuff that's going to be in this upcoming video is going to be a bit less crispy than it should be, and YouTube compression is going to be eating up the video way more than if it had a 4K image to work with. But, well, it's either that or no video at all.
I'm fine with 1080p. Don't have any devices who can show anything better.
Yeah, I mean, for the longest part, for the longest part that I've been uploading 4K content, I didn't have a 4K screen either. But I knew that even switching to 4K on a 1080p monitor in YouTube is still going to make the thing look so much crisper. But yeah, I guess we're taking a step back here.
Yeah, look at your stats. 50% of the people are watching your videos on their phone. So
phones are more than 1080p these days.
Yeah, but you aren't probably able to spot the difference between a 1080p and a 4K video.
Yeah, absolutely. Well, you've been working more in the practical realm recently, Stefan, right?
Yes, finally. So one thing I have been asked for like all the time I've been making YouTube is can I get the plans for your universal test machine? And the universal test machine, or I often call it my tensile test machine, is really the thing I built my channel on. This is the machine where I do my tests, where I gather all the data for my filament samples and everything, and which kind of set me off from all of the other channels out there besides you, because you also did it in a really good manner. And I have been putting that off because at first my code, my Arduino code that I had been writing just looks horrible. I didn't have any plans for the electronics, so I had to reverse engineer everything, even though it's not that complicated, but I just hesitated to do that. And now I finally I'm currently working on it. I'm putting together the electronics. Still suck at making schematics, so everything will be out open source, and I hope for contributions for people probably making some real PCBs that if somebody's interested in making that machine can just download the Gerbil files and order them. Software, I'll be adding some comments and
yeah, but that's like the state of pretty much every single project that you work on and people want to have. But usually when you make something, you're in the flow and you just create to get the job done, right?
Yeah.
You don't really think about, hey, how do I polish this up and how to make this in a way where somebody else is going to be able to understand it. But people are still happy if you give them that raw, uncommented, somewhat working code that you have.
Yes.
It's better than nothing. It's better than not releasing.
Yeah, definitely. But still, you are kind of a perfectionist. Yeah, it's working for yourself, but if you want to put something out there, it should at least be in a form that also makes you happy. And this is just, the last 10% of a project always takes so much time. And this is the thing, currently putting all that together, do some documentation, gathering the CAD files and everything, and hopefully, like maybe in 1 or 2 weeks, video will be up. The GitHub is already up with some of the files, but then everything will be available, and people can build one of those machines on their own, and it's really interesting. So I got tons of emails from people who also want to have one of these machines, and not all of them are the 3D printers that want to test their filament samples. No, there have also been people who wanted to test zip ties. Zip ties? No, not zip ties. Reißverschluss, zippers.
Zippers, yeah.
Zippers.
You can also test zip ties.
You can also test zip ties. It's called a universal test machine. You can kind of put everything in there and destroy it in a controlled manner. Take the test data, compare things, and improve yourself. It's a cool project, but as I said, it's just taking a lot of time to put everything together, and at least making me kind of happy putting it out there. But I'm really looking forward to other people contributing to that project.
So you're putting that up on GitHub, right?
Yes, I'll be putting that up on GitHub.
Yeah, so you're not charging anything for it, so just put it out there. People can send all the pull requests they want, and then they can fix it up. Yeah. But just to summarize, so the universal test machine gives you basically 2 points of data. The first one is, basically it breaks things, right? It pulls them apart. And it gives you the data for how much it stretches and at what force it stretches. That's like the idea.
That's, the test machine only, destroys parts at a controlled speed and gives me the force. The strain is something kind of different, which I do with an optical extensometer. So I kind of put a additional camera in front of the machine, mark 2 points on the sample, record a video, and then use the motion tracking feature in Blender to track these points over time, and then calculate the strain from that. So this is something totally different to that. You don't need that for, and I also rarely use that for my tests, because it's kind of a lot of work, but they're kind of different things. I'll show how I do everything. And there would actually be the possibility, and probably if I wouldn't have started YouTube and would use this machine like every day, I thought about adding a Raspberry Pi in front of there with a camera and using some OpenCV to automatically track the points and everything, that you have like kind of a real tensile test machine. Right now, it's still lots of manual work, but I just do not have the time to make everything nice and pretty. It needs to work for me, and I don't use it every day. So, as I said, I'm looking forward to contributions and to people who know better what they are doing in terms of electronics and programming, and contribute to the project and make it better for everyone.
Yeah, sure. I mean, that's how RepRap got started as well. People even just put their ideas out there without anything really finished behind it, and other folks came in and helped on that.
Yeah.
So I think that's going to be fantastic.
Yeah, definitely. And well, speaking of my projects, we've already been talking last time about CNCs, PCB milling, and things like these. So I've been using Gerbil on my CNC router for the last 5 years, and I finally got a new machining PC and installed LinuxCNC and tried to run that machine with LinuxCNC, just because it's giving me a little bit more options. It's a little bit more reliable and kind of a better, proper setup, making it more like a professional CNC.
So what parts of the process does LinuxCNC handle?
LinuxCNC is more or less the G-code interpreter. It's the GUI that you also use to control the machine, and it's creating directly the steps for the CNC machine and sending these steps over just like a normal parallel port cable to the stepper motor drivers.
Right. So it's taken out the Arduino that would typically be controlling your stepper drivers. Instead, you just hook them up directly to your PC.
Exactly. Because before, I always used my laptop, had the universal G-code sender on there, connected via USB to an Arduino, and then the Arduino did all the interpreting of the G-code and then sent the stepper signals. But USB always had some issues. Gerbil is a great software, but it's kind of limited from time to time. You can't do any backlash compensation.
Right.
And just other things are not as nice as it could be, just because it's limited by its resources. And trying to use LinuxCNC now is for me a step into getting into a more professional CNC environment. And LinuxCNC is kind of comparable to Mach 3, and I think Mach 3 is actually based on LinuxCNC, or the other way around, something like that.
Not sure. I've never, when a few years ago when I started, getting into CNC, I never really understood what Mach 3 was actually doing and what its purpose was. Personally, I think the idea of using a parallel port is just, it feels so archaic to me. It's just, you can't even get a computer that still has a native parallel port. It's always through adapters and through, USB dongles, essentially. Is that working out for you?
So I started with one really old Pentium 4 machine that still had a parallel port on there, but it actually was kind of too slow for getting everything working properly.
But it had 2.8 gigahertz. Come on.
Yeah. Compared to the 15 megahertz of the Arduino. And then a friend of mine told me that he still had a bunch of old PCs in his basement from his company that they don't use anymore. And this is an i5 third generation. I don't know. Really good machine still. And I installed it on that machine. That's just working great. It's really working great. And since, so LinuxCNC is running on Linux, and this is not a real-time operating system. Yeah. So latencies need to be really small. Otherwise, just the step, the duration between the steps will not be precise. And this was the problem with the Pentium 4 machine, that there was too much variety in the step duration, and the new one is able to handle that pretty well.
I mean, you can get real-time kernels for Linux, but I'm not sure if LinuxCNC actually makes use of that.
I actually might have been talking crap, but I don't really know that much about Linux. I have to really be sorry. But that's how I understood it. And so far it's working out pretty nice. It's free compared to Mach 3, because Mach 3 is like 150 euros, which is then running on Windows. The community is bigger for Mach 3, but I just thought that it would be working. But you have also been machining your first PCBs. How did that work out for you? And where did you do it?
Say again?
And where did you do them?
Where did I do them? My usual studio. I did them on the CNC router.
With the Bosch router on there?
Yeah, it's a Makita router. Makita Palm router.
That's kind of overkill.
And, yeah, it does 30,000 RPM. So it's in the right ballpark. Yeah, so that machine is not running LinuxCNC. It is the classic Universal G-Code Sender plus whatever cam you want, plus Gerbil, of course, with a CNC shield. It was a bit of a rough road, which is, why the video that I today uploaded was 35 minutes on that topic. I kind of had too high expectations for the machine and for the process. So I guess the biggest thing I wanted to do is to have a PCB here. I guess, yeah, so this is one of the modules. YouTube viewers, you're welcome. Audio viewers, I'm sorry. Module, it's a PCB that's going to plug into the PCB I make, and it has the standard 2.54 millimeter, 1/10 of an inch grid. And I wanted to have traces go between the pads where the female headers for these would come in. And that didn't work out. Not at all. I tried with an engraver first. The engraver just snapped all the time. The tip just kept getting shorter and shorter and wider. So my milled out traces kept getting wider. So that's not a fantastic start. So I switched over to an actual 0.5 millimeter end mill. That worked fantastically, but it meant I had to redesign the PCB. And actually, is it a PCB? The board. The milled board.
It's an MCB.
Yeah. I don't know. I'm pretty sloppy about that in the video as well, but yeah, I switched over to a much wider trace width and a much wider isolation width, and that worked out beautifully. It's just that it, not being able to route between pads makes it a bit more limited for what you can do. I was able to route all the pins on this little daughter board to the appropriate connectors on the main board if I had been able to have traces between pads. I'm sure. But with this, I had to strip out like 12 signals, which were optional, just so that I could go with a single-sided PCB.
Okay.
But I'm capable of making PCBs now, and watching the process is actually super fascinating. The milling part, not impressed, but the drilling actually is what I find the most satisfying, because you're making like 0.8 millimeter holes, and they're like precisely positioned every single time, and they come out super cleanly. That's fun. That's good fun.
But what do you think was the problem why you weren't able to do these small trace spacings? So do you think it is the run out of your Makita router? Do you think it's the sloppiness of the CNC? Is it the thing that your PCB wasn't 100% level? So I would be interested to hear your thoughts on that.
That too. I think it was a bit of all of them. So that I'm pretty confident that the PCB was level because I planed down the bed before that. So it should be as perfect as it gets. So it was level, but it looked like it was not level because I think the tip of my engraver bit was breaking off. I was using a 15-degree engraver bit, which is probably a bit extreme, but I wanted those fine details. So the tip is like really, really tiny on that. And even with the bigger end mill that I ended up using, you could still see that there is a ton of backlash in the CNC. It does have, I think it's a 2-star lead screw with like one of those spring-loaded Delrin nuts. So it has like a backlash compensating thing, but you know how well those work. So there is a ton of backlash in there, and that of course makes milling out small traces kind of hard. The other thing is, of course, with that Makita router, because it is, it's essentially a wood router. You use it for milling like chamfers on a piece of hardwood, not for making, 0.05 millimeter traces on a PCB, on a circuit board. So I think the original chuck, it's like a It's not quite an ER collet system, but the original collet in there is pretty good. It comes with a 6 and an 8 millimeter collet, but of course your engraver bits or end mills that you use for PCBs are not that size. They're
1/8 of an inch.
1/8 of an inch, yeah, 3.175 millimeters. And I had to use an adapter collet. I bought like 3 different ones, and there was one in there that with the right orientation between the original collet and the adapter thing kind of was working well, but it's just not reproducible. And I think I had a ton of run out on that engraver bit. So that's kind of a death sentence for a sharp engraver like that, because it's not going to cut on the actual cutting face. It's just going to smear through the copper. And yeah, overall just not made for that sort of precision work.
I think for such an application, actually a modded 3D printer is is the better option, because it kind of doesn't have any backlash due to the belts you're using. Compared to even the backlash compensated lead screws that are in yours. And the cutting forces, they are minimal. So the 3D printer is usually sturdy enough to
absolutely
just run a small engraver on there and do your PCBs there. Which is kind of interesting, but if somebody's thinking of getting into that, modding your CNC router as your 3D printer is fine. And there are a couple of videos actually also on YouTube. I think Tech2C did something on that.
Yeah. So for mounting an actual milling spindle on a 3D printer, I think the biggest issue is resonances. Not that it wouldn't be rigid enough, but just that, at a certain RPM and cutter geometry, your thing is just going to start to resonate, because it's not a very rigid system, but it's very precise. It can position itself very well. So for milling out an outline, I don't think a 3D printer is going to be the best tool, but at least for engraving, traces, it's going to work pretty well. Because you bring up Tech2C, so this project, this milling project, was just step 1. Because that's like the obvious route. I still want to do that thing where you have a marker in your 3D printer and actually paint out your traces on your raw copper clad and then etch that away. So anything that is not painted gets etched away and gets removed in the copper surface. And Tech2C is one of the guys who did a video on that topic, outlining a few details. Some of his tools aren't available anymore, so I kind of want to rehash that idea. And actually, my pen holder that I found on Thingiverse is going to be inspired by Tech2C's original design.
Maybe just staying on that topic for a second. We'll get to other questions in the end, but I kind of remember that there was one question in the comments. If you have already tried out to 3D print directly on a piece, on a PCB, in order to use the plastic as copper clad, in order to use the plastic as isolating material before the etching process.
As the etch resist. I think that the bigger challenge is getting it actually to stick to your copper. I think something like a flexible might work for that, because those tend to be really sticky and really well bonding to those surfaces. But copper in itself, unless it's really clean, I don't think makes for the best surface to 3D print onto.
And actually, if you just have a simple adapter to your printer, just using a pen for drawing your traces on the copper clad is the easier thing. The only downside of that method is if you use kind of an etch resist, is that you have to drill the holes, the through holes, manually later. And this is the really nice thing if you do isolation milling of circuit boards, that you can do isolation milling and directly drill all of the tens or hundreds of holes on your PCB, and it's just pleasant to look at.
Even with tool changing, as long as you turn off the XY stepper motors, you can just open the collet, put the drill bit in, and you're good. I was using flat cam for the milling, so that even allows you to do milled holes. So if you have a 0.5 millimeter end mill, you can mill out your through holes of any size with that, which is, I think, really nice. I just use the same drill bit for everything, but that is also an option. I mean, what you can still do is to paint or draw some fiducials on your PCB. In that case, it is actually a PCB, yeah, if you do it with a 3D printer and a pen. Draw some fiducials on that and then align it on a CNC later.
Yeah.
Though, with the marker tips that we have available, I don't think you even get much of an advantage, by doing it that way, not just milling out the entire thing in one go.
And how did you handle solder mask? Because when I did my first my first circuit board, which I isolation milled, soldering parts on that is kind of hard because the solder always bridges over the gaps you did.
Yeah, I'm just good at soldering. Even if YouTube comments don't believe me, no problem.
We'll see that.
Yeah, the solder joints came out kind of messy. It's just so I ended up routing the isolation tracks with that 0.5 millimeter end mill, or you can get those specialized PCB milling bits on AliExpress for a few cents. They have kind of a diamond grid pattern on them, and it leaves a relatively wide track compared to engraving, at least. And that was enough to, if I was careful soldering it, make sure I'm not bridging anything, or at least if I did bridge it, I had to go back and kind of clean it up again. But yeah, was not that big of an issue.
Did you only use through-hole components, or did you also do surface mount?
No.
Okay, yeah.
So very simple starter PCB. Again, it's basically an adapter board. It's like a adapter board. It's like a kind of a dev board kind of thing where this is an audio DSP board with one of the analog devices, DSPs on it. That fits on there, a small DC-DC converter, a small amplifier, connectors, that entire thing. There are no actual components. So active, passive, whatever components, just mechanical connectors on that board.
I don't really want to spoil anything, but I have seen that you've been working on some remote speakers. Does that something have to do with that?
That's that direction. Yeah,
cool.
Yeah. Again, when this podcast is out, I hope I have the video published. But yeah, that's the idea. So audio DSP. Eventually, I do want to have like a DIY Bluetooth speaker, something along those lines. That is programmable, that you can adjust the sound with, and it's just a learning project, and it's fun for me. I enjoy audio stuff a lot.
Cool. Yeah. So
all right, projects covered.
Next thing is news, and
what a shocker!
What a shocker! Yeah, we have already. Go ahead. No, go ahead.
Okay. Shocking news of the week: commercial 3D printing company charges money for their product. It's
well,
yeah.
Yeah, Simplified 3D announced that they will be charging an upgrade fee for their version 5 of their software, even if you have already bought one of the older versions. And this has been upsetting some people. And I have been thinking about that topic for a couple of days when I have seen it, and I have my opinion on that. And I think that it might not be the most popular one. So viewers and listeners, please, listen to what I have to say later. So what do you think about that? You have already said, commercial company charges for an upgrade.
Okay.
What do you think about that? You haven't been using Simplified 3D. Well, you have been using Simplified 3D barely.
Twice.
Yeah. So.
I've used it for G-code viewing, and I've never really had the need to use it because I'm happy with the support structures that I get out of, Slickview or Cura, and I'm more happy with using the features those have than what Simplified 3D does. But feature-wise, I mean, that's a whole different discussion. So, okay, Simplified 3D. paid for slicer. Commercial company, not open source, not a charity, not anything. They're a corporation. Their goal is to make money, right? That's the base premise. So you buy a Simplified 3D license. It's around $150, and basically their promise is you get a software, you get the current version, and then free upgrades for major versions for the next 12 months. That is like basically what they're guaranteeing. And people that have bought version 4.x recently will get that free upgrade to version 5. But people who have bought, version 3 or 2, or I think there was a version 1 at some point, are not going to get that next big upgrade, at least what they're announcing, for free. And I mean, that's upsetting people, but I don't see why it would upset you. I mean, yeah, I guess it's that understanding that software is a service now, and, Creative Cloud and Windows 10 and all these other tools are kind of more a subscription where you, either get it for free and then pay with your data, Google, or you pay a monthly fee, like with Creative Cloud from Adobe. And then you get all the rest for free. You get so much included just as a flat rate. But Simplified 3D is not that. It's a one-time purchase, and people have been pointing out, hey, why have you not switched to a pay-as-you-go subscription model? Because it seemed like they were kind of running out of cash in the last year or so, because updates were slow, communication was slow. So that might have been just a bad business move, but whatever. I don't see that Simplified 3D is doing anything wrong with charging users for their software. I mean, that's their base premise, right? They're a paid slicer.
Yeah, definitely.
What I do see a problem with, though, is the way that timing, essentially, what it comes down to. Their version 4.4, I think it is right now, 4.x, has not been the most critically acclaimed version of their software, with people running into issues where they couldn't download profiles, with bugs that they ran into that made it unusable for them, with just not being stable. It was just not the quality release. And now they come along and announce, hey, actually, to fix these things, that's what it's coming across. To fix the problems that we introduced, we're going to charge you an extra. It's probably going to be somewhere in the neighborhood of $50.
Yeah.
That is unfortunate timing. So not the best job on communication, but in essence, like, guys, what did you expect? Seriously, you bought the software. It said on the tin what you get, and you got exactly that.
Yep. I think what also makes people upset is that they are used to having free updates to Cura and Slick3R. Since always, but both of these slicers have, Cura has Ultimaker in the background, so they are developing Cura for their Ultimakers. And I think in a way to also develop and make their brand more noticeable, they are giving the slicer, away for free. Slick3R currently is mainly developed by Prusa. So
Slick3R Prusa edition. Yes, there is still the mainline slicer Slick3R that is developed by Alessandro Ranuccelli.
Ranuccelli?
I don't know. I keep messing up his name. I'm sorry, Alessandro.
So but the main development on Slick3R is currently done by Prusa in their Prusa edition.
They're separate versions and they're kind of catching up to each other, but
And they kind of have to give it away for free since it is an open source project, but it's also kind of publicity for their printers because the name Prusa is like in every head. And I totally understand that Simplified 3D is now charging for their upgrade. They have people they have to pay. They have programmers they have to pay. If they don't have any money coming in, they can't pay them and they can't do any upgrades. And as you have already said, it's a bad point at the moment because there are lots of things going on where people are not that happy. In my opinion, they should fix version 4.1, that this is a release that is properly working, and everyone who doesn't want to purchase the upgrade can use the latest version with all of the functionality working, all of the profiles being downloaded. But everyone who wants to get, new features, they have to pay for the new version, and that's totally fine. Every commercial software has paid upgrades. That's normal. Many people many software companies have been changing to the subscription model. Yeah. But it's totally the same. You get free upgrades, but you pay a monthly or yearly or weekly subscription. And I think it's fine. I think that the thing that will be really challenging is, can they really pack features into their version 5 which make it worth purchasing? Because if they kind of just do a bug fix in version 5, people will stay in version 4.
Supposedly version 5 is going to be a big feature upgrade
they have already been saying that for version 4, and it was just some minor things, and we didn't really see something really major that Simplified 3D was known before. And they were known before for their great supports, and they have been relying on that fact being the slicer with the best support algorithm for like years. But if they don't really bring a big benefit into the 3D printing community, I think it's going to be hard. I think it's really going to be hard for them.
Yeah. The thing is, when Simplified 3D first came out, Slick 3R, Cura, Skyforge, I don't think that was around anymore, but those were so far behind what Simplified 3D had to offer. And piece by piece or step by step, the like unique features, the unique selling points to Simplified 3D kind of got stripped away and got implemented in other features, like the entire thing of processes in Simplified 3D. Oh, you can do this object with that, and you can this. Slick3R does that too. You can set properties for every single object. You can set per layer properties. Like, not a big deal. You can do that. And then also stuff like Octoprint integration. That's not there. Multi-material support for the Prusa MMU1 and MMU2 still not there. And yeah, it's for sure going to be an interesting time for slicers this year. Not just because of Simplified 3D, but yeah.
I know what you mean. We might be talking about that in the next podcast.
Yeah,
maybe.
Let's see.
Let's see what's happening.
Cool. Though I gotta say I have more info on that than you do.
Well,
whatever.
Yeah, don't want to talk about that now. Topic of the week. You have been sending me.
Let's switch topics really fast.
Yeah. You have been sending me a link to a article covering the new superfast DLP printing, which the MIT has been showing off recently.
Yes.
Can you tell me something about that? Because I just briefly scrolled over the article, but didn't really get all of the details there.
Okay. First of all, is it GIF or is it GIF?
It's GIF.
Okay, we'll agree to disagree. So they've got the MIT Technology Review, and where's this from? University of California, Berkeley, and Lawrence Livermore National Laboratory have developed a novice approach to resin 3D printing. And typically you have your DLP, SLA, MSLA, MDL, whatever. You have your resin printers, and they build the object one layer at a time. Basically what they are doing, and they have very nice GIFs of this project, of this process, is they have a spinning
vial.
A spinning vial of resin basically, and they project an image of what they want to make through that entire resin, and only the areas of that resin that receive enough light from the projector actually harden. So they've got a second counter here, and it looks like it's within a minute you have a solid object that is basically whatever the size of your projected light area is. And that is basically the premise here. You can have super speedy, super fast replication in this one process. Of course, it is still resin, so you have all the pros and cons that come with that. And I think the biggest downside is that it's not particularly detailed. Of course, you can spin it the other way around and say, hey, we don't have layer lines, we don't have ridges in this thing. But because you're not like precisely exposing individual, let's call them voxels, individual 3D areas of space, you're just shining it through the entire resin. It's still kind of hard to get that really crisp print. I can also see that because you're shining light through the entire resin, the resin itself is only going to be single use because you're partially exposing the entire thing at once. But yeah, it's if you just need a really fast, really coarse 3D print, that might actually be a very neat approach.
Definitely. And well, I think at the moment it's currently just a proof of concept. So like details might improve in the future. It kind of reminds me on the process that they use to manufacture these, do you know these like glass sculptures where they use a laser and focus at specific points in the glass where it creates micro cracks, and this way it creates a three-dimensional objects in the glass. They kind of use the same thing. They project a picture in there, and at the layer or the surface, the plane where the focus is, the intensity of the UV light probably is high enough to cure the resin. And hold up. This is not about focusing the light on a single plane. This literally shines, if you have the spinning GIF where they print the thinker. It's not focusing on a single plane. What you actually see in that GIF is it being projected from the side. So it literally exposes that entire ray of resin all throughout the material, and wherever you have enough accumulated light in a single point, that's where it actually pushes it to be fully hardened. So you kind of project like an X-ray picture of the part in there, and this is like reverse CT scanning. This is basically cool. Wow, now I understand it. That's so cool. What it is projecting, I'm sure that there's an algorithm behind it that makes sure that certain areas aren't overexposed and that, it all adds up correctly. But basically, if you have that, shadow wall kind of play where someone stands behind an illuminated wall, that's what gets projected through it. And it just, the photon exposure accumulates. That's cool. Because I already thought that, this sounds really interesting, but you get lots of light on like the rotational axis, and also the resolution of your part will be worse the more you are away from that axis. But if you do it that way, and if you take a look at the accumulated light intensity at a specific voxel, the resolution should be kind of equal in the whole vial there. Oh, that's cool. Yeah, I think technically there would probably be a lower resolution the further you go towards the outside, I think. But you may not have as much control over like that very center column that is always... I'm sure that they've solved that somehow. Maybe they haven't, but definitely a very, very cool process. Yeah, that's totally cool. Yeah, check out the GIFs if you get a chance. And if you don't understand what Tom meant, check out the GIFs. And if you have your own opinion, if you call it GIF or GIF, in German I would call it GIF, but I think the proper English pronunciation would be GIF. But let's don't talk about that. It's the graphics interchange format. Graphics. Yeah, graphics. There's a G in there. Is it then GIF or? Yeah,
graphics interchange format? It's GIF.
GIF.
Graphics, yeah. Sure.
Whatever. If you guys are interested, on that topic, take a look at the show notes. There will be links to both of the articles and the GIFs.
Yeah.
Damn, I totally forgot to talk about one of the things we wanted to add to the podcast today. Favorite gadgets of the week.
Yeah. Non-3D printing stuff
we totally enjoyed this week.
That we were surprised about. I don't know if guys let us know in the comments. Do you like this? We're probably starting off very poorly here. But yeah, I'm just gonna go ahead and hold these in the camera. I've been using as my standard headphones. I've been using these $25 Anker Soundbuds Slim. Good pair of headphones. They have the batteries in the earpieces, which kind of makes them fall out of my ears and they don't fit perfectly, but they're cheap. They're okay. They're fine. But unfortunately, they keep breaking after 9 months. Anker replaces them. No questions asked. Like you say, hey, I broke these. They just send you a new pair. So fantastic service. But this is like the third or fourth pair that I'm on, and I'm getting tired of these. Instead, I got these Huawei headphones. These are the WH06 something, and no, they're called the AM61. Yeah, and this is the first time that I've had headphones that actually fit in my ears, that really fit snugly into my rather large-sized earlobes. These are fantastic. They sound kind of weak when you start listening to them, but they have that analytical, non-boomy, what's the brand? Beats by Dr. Dre. They don't do that. They sound relatively clean like that. I like these. Battery life is fantastic. Sound is okay. New favorite pair of headphones. Love them a lot. If you want to check them out, links in the description. You can get them on Amazon. They're around $35. Definitely worth the money.
Cool.
Stefan, how about you? You've been teasing me before.
I've been teasing you. I finally retired my Pebble Time. So smartwatch.
Oh, yeah.
Yeah, I had a Pebble Time for the last 3 or 4 years, and I was really upset when they stopped making the Pebble Time 2, and then Fitbit bought Pebble and kind of made all of the old Pebble watches unusable anymore. And I have been dealing with that for the last 6-7 months, and none of the functionalities didn't work properly anymore, and I was looking for a new smartwatch. Since I don't have an iPhone, I didn't buy myself an Apple Watch, even though I find the Apple Watch kind of appealing. I have to be honest, just how it looks, how it works, and I have the problem that I have really small wrists. Do you say wrist? Yeah, wrist. Yeah. Wrists. And so Mikuláš from Prusa. I have been meeting him this...
The video guy.
Yeah, the video guy. I've been meeting him this year at Formnext, and I have seen that he was also wearing one of these smartwatches, and asked him what he had, and he had one. I think it was also an Amazfit watch, which is made by Xiaomi, also Chinese brand. Right. And so I bought myself
we're
the Amazfit BIP, which is kind of nicely suitable for small wrists. And
it looks like an Apple Watch on first glance.
It looks like an Apple Watch. The only thing which is really ruining the looks is the Amazfit logo right here in the front, which is kind of, I don't know. The thing, what I really like about this smartwatch is that it has supposedly a battery life of 45 days. So
45 days. Does it have an e-ink screen, or how does it do that?
So even the Pebble Watch didn't have a real e-ink screen. It was an LCD, which was working if you had light from the front. And this is the same. So the display is not nice and crisp, but it can be readable all of the time. It has automatic light when you put it into the right posture. And well, I've been wearing it now for like a week, and the battery has drained like to 80% or something like that.
Wow.
It's great. And it has heart rate sensor included, which also seems to be working. I haven't compared it yet against my Polar heart rate belts.
Yeah, but heart rate is I think pretty easy to get right.
Yeah.
It doesn't have the blood pressure thing that the Apple Watch now does, right?
Nope.
No. Can you do phone calls on it?
No, it's
No?
it has
Okay.
Bluetooth connection. It will show you notifications. It will show you when a call is incoming, but it's really bare bones. It's $80 compared to like, I paid $250 for my Pebble Time, but it has Gorilla Glass 3 on the front. The thing which I don't really like is that it can't show Umlaute like and Ü and scharf S and smileys on the screen, so you only get question marks when you get a notification where this is included, which kind of sucks. And it is not properly water resistant, so you shouldn't even shower with this watch.
Okay.
I already did it. It's not broken yet. But yeah, what can you expect?
It just doesn't have the official
$80?
rating, right?
It has IP67, I think, but
Well, that's waterproof enough,
Yeah.
water resistant enough, and it doesn't run Android Wear, I assume.
no, something which they did on their own, and this is one of the reasons why I think they also get away with a 45 days of battery life, because this is really just bare bones. And they have some really other ones that are a little bit bigger, which look really nice, but yeah, just my wrists are not big enough to kind of wear them. I'm happy so far with this new watch. Let's see how it will turn out during the next couple of years.
Yeah, I'm just not a watch guy, and honestly, I also sometimes just enjoy not having a device that is screaming at me. But you do you, Jiff man.
Yeah.
Cool. Should we answer some questions? We have, I think, some really good ones from. Are these from YouTube? Yeah, these are from YouTube.
Yes.
Do you want to start out with the first one?
It's so long. Do you want to read it?
Okay. Sales Maxfor is asking, hey, I would really like to know your opinion on MMU printing. I think I have not seen a video from you two on that topic. I've seen that Stefan has a dual extruder printer in the last video, so I assume or hope Stefan is going to talk about that soon.
I actually already made a video on my dual nozzle TiVo Tarantula like a year ago. This was my first experience with multi-material or dual nozzle printing. And I also have an Hictop Duale 3 IDEX system, so with two individual extruders, which I got as a pre-production unit, which is horribly loud, but and that's the reason why it's currently in my basement. I don't use it that often, multi-material printing. One of the reasons is that it just slows down printing quite a bit and makes preparing models quite a lot of work. But sometimes there are applications for that. And I think the most important application, in my opinion, is soluble support material. And I think you also have an Ultimaker 3?
Yeah, I have the Ultimaker 3, Sigma R17, Atom 2.5EX, which is a multiplexer, and the multi-material one from Prusa. So plenty of options there as well. Yeah.
But do you use them often?
No.
Why?
Because it's a pain to prepare stuff for them. When I design things, I usually design it either as a supportless print or as something that needs very minimal support. And yeah, again, the only real application as an engineer I see for these is that we have that PVA soluble support, but PVA in itself is also such a material that such a pain to work with that I don't feel like going through the effort. So quite often I just use regular support.
Yeah.
Of course, multicolor is fantastic. there's not. I wish we were seeing more multi-material where it's two different properties of material that get mixed together, or well, not mixed, not blended together, but used in the same print where it's flexible and rigid, or.
And this is, I guess, what Sales Max4 is talking about. I don't know if you have watched my latest video about smart infill.
I still need to watch that. Sorry.
There I kind of use infill modifiers that I extract from topology optimization and put them in my 3D prints in order to have 100% infill at the location where the material is really needed. And I thought for visual purposes, it would be nice if I would use transparent PLA for the outer shell and use red PLA for all of the areas where it is strengthened. And that looked really, really great. Wait a second.
I've seen the thumbnail. It looks fantastic.
But
for something like that where you actually have 100% infill, it does make sense to do like just a classic dual extruder, different nozzle size. That's of course something you can do with a actual dual extruder printer, not with an MMU, but with a dual extruder setups.
But the thing that was popping up in the comments was if this would be something where you could, 3D print like the outer shell of the part in one material and use another material for infill, be it reinforced materials, be it something more soft, being something more rigid. But this is something which hasn't really been I think, investigated much in the past, but there would be probably some cool applications for that.
I'm trying to think what would make sense, whether you have like the eggshell approach where you have your hard shell and your soft inner core. But that, I think, would just make your part extremely weak because you don't get the support your shell needs.
Yeah.
Or you have basically an inner part that you coat in a soft touch material. I think that would be something that's nice. I mean, like cordless drills do that, where you have just a thin shell in the gripping area where it's molded on rubber that makes it feel better and grip better. But I don't know, combining different properties. Maybe if you have like an old PLA that you want to get rid of, you use it for the infill, right? But I don't see a lot of applications for infill and shell combinations.
Yeah. I'm also thinking about that topic. I also don't really have a proper application for that at the moment. I don't know if you listeners or viewers have any ideas. You can leave them down below. As you know me, if there's something interesting popping up, I might be investigating that because I think it's an interesting topic and it might lever 3D printing up a little bit to applications we did not see it being used before. And I'm quite happy about what I did there. So dare you watch that video?
I'll catch up on it. Yeah. But I guess to close out this topic, MMU printing. I guess we did talk about this. We really need to start a list on the topics we've covered. MMU versus IDEX or just dual extruder. I mean. Yeah, MMU I think is a bit better for multicolor because you don't have the hot ends heating and cooling all the time and needing to reprime each one. But for actually mixing materials like a PVA and a PLA even, I don't think MMU or multiplexing setups are the best choice necessarily.
Yeah, me neither. But it's a simple solution and kind of upgradable for other machines and kind of saves you the hassle of calibrating two nozzles to each other.
Yeah, just a very simple, very elegant approach in that regard.
Yeah. All right. Next question. Joel.
And the last one for this video.
And the last one, yeah.
Well, this podcast.
Joel Driver's asking, Tom, would the O-drive be an option for your arm snapping 3D for your arm? Sorry. Let me start over again. Joel Driver was asking, Tom, would the O-drive be an option for your arm snapping printer? Would like to hear both your thoughts.
And
so what's the O-drive?
Simple. Yeah, okay. So the O drive is basically a servo controller that you hook up to a brushless DC motor and an encoder, and it runs it as a servo. It's an open source platform. It's relatively affordable. I think it's somewhere $150 for a dual drive unit that does kilowatts of output. And yes, I have specifically looked into the O drive for that ultimate 3D printer approach where you just ignore accelerations and just keep going and keep the hot and happy at a certain flow rate. So yeah, very much an option.
Cool.
Stefan, what's your opinion on the, or your thoughts on the O drive? Have you checked it out? I've seen it at Bay Area Maker Faire.
I have heard about it, but I haven't really looked too much into that yet. I'm thinking about upgrading my CNC router with servo motors, but at the moment, I'm not really that much into servos.
Yeah, the thing is, for let's say regular 3D printers, we have a relatively weak frame and relatively weak belts. Just the O drive is a bit. Just a tiny bit overkill, because you see I've got a video up on it on the channel from last year's Bay Area Maker Faire. That thing hoons. That thing just goes like crazy. I mean, you have belts, you have your 8mm round rods that you're gonna be in wobble hell.
But you have said that this is an open source system, so do you buy the encoder and electronics separately to your motor, or is it like a whole package which comes with the motor and the encoder and the electronics which make it a servo motor?
They do offer both. So they have their O drive board, their O drive 3.5. I've just opened up the shop right there. They sell the board itself, which is either single, dual outputs, etc. And then you can also buy motors that they know work with this. And yes, they have dual shaft motors. Of course, one side is the drive set, the other side is the encoder in 2 different speeds. They also have an encoder set that you can buy with it. So you can get like the full motion system from them. Or you can, of course, mill your own PCB and build the thing yourself.
Challenge for you.
Yeah, I don't think that's going to happen anytime soon. I've not figured out soldering SMD components like that yet.
Yeah. All right, and I think that's it for today.
Absolutely.
Thanks everyone for your time. You can.
Yeah, thanks, Stefan, for being here. Time is passing fast. Yeah. I mean, it felt like a short episode, but
over an hour again.
Damn. But we've heard you guys like that. You guys like it long and slow.
And on that bombshell, see you guys in 2 weeks. Bye.
Yeah. See you. Thanks for listening.